Hello everyone. In the previous video, we have seen some of the concepts that is delegation, and we have seen this window example wherein the class window is used as a base class and rectangle class is used as a derived class, and the operation, the same operation which is there in the window class is inherited in the rectangle class to draw a specific uh, that is a the rectangle. So since the class name is rectangle, it draws a rectangle. If at all you want any other figure to be drawn, you can just call this function and then you can make the work done by that window class. And we have seen some of the advantages of that and disadvantage of the delegation. Delegation is mainly an assigning the responsibility for the others for accomplishing the task to be done. And the next part is what is designing for change. Designing for change, see, the key to maximizing reuse lies in the anticipating new requirements and changes to the existing system. Whenever we are building any software or software architecture, there is one concept which is to be kept in mind, that is whether it is a reusable or not. It's not that if you build any system and if it is not reusable, then you cannot say that my system is an efficient system. Any software or any application or any software architecture, once if it is built, and it should be reusable. Reusable is one of the most important parameter which is considered in the software development, and the design that does not take change into account risk major redesign in the future. If at all you don't take care of that change that can be accomplished in your software, then it is a major redesign of the whole architecture itself will change whenever if you want to update or if you want to do some settings, some change in that particular software. And any operating system, that is if you see an Android operating system and different operating system, there will be an option called as update means what, some new features will be added for that. In the same manner here also, whenever you are designing any application, that should be easily, it should be accomplished. And here are some common causes of redesign along with the design patterns that address them. Creating an object by specifying a class explicitly. It means that there should be one common class. Whenever you make some change in that particular class, that should be affected to the whole application. Dedicatedly one class or one object which should be there, it should be there. Whenever you change that particular class, that should definitely affect to the object, and then whatever the change if we are doing, so then it will be uh, accomplishing in the entire application. Dependency on specific operation. When you specify a particular operation, you commit to one way of satisfying a request. By avoiding hard coded requests, you make it easier to change that to either at a compile time or a runtime. Dependency on specific operation. Specific operation means, so suppose if at all you want to solve any issue in that application, only that itself has to be modified. There is a word written as a specific. Specific means if any particular application is having certain problem, only that has to be modified without disturbing the entire application. That too, it may be during a compile time or whenever the software is running. So that is called as a dependency on a specific operation. Dependency on hardware or software platform. What is this? If the whole explanation is written over here, then let me explain that in my own words, and you can get to know what exactly dependency on hardware and software platform. See, any application if you are building or any software if you are building, so that should be compatible with the hardware. So by checking that itself, you will be building an application or you will be developing an application. So there will be a hardware and software compatibility. So if at all coming days, if you want to change any software or if you want to change any hardware, At that time, it should be easily able to change either a platform, hardware platform, or software. Software in terms of the versions, maybe we came up with a uh, with the Windows 98, 95 even, and Windows 2000 and Windows XP, so Windows 7. See there, now the softwares are getting changed. So early days, what we had a concepts like Core i3, i5, i7, like that. Okay, hardware and both software both are upgraded hand in hand. So you should not feel difficult for your architecture to grow up or the architecture to change. So there will be definitely dependency between a hardware and a software platform. Dependency on object representation and implementation. Clients that know how an object is represented, stored, located, or implemented might need to be changed when the object changes. The objects are used for representing. That is, objects hold some information. That holding that with that information, we can able to perform many tasks. So dependency is also there on the objects representation, in what way it is representing, what is that information it is hiding. Through objects itself, we can accomplish our task. Algorithmic dependencies, based on what algorithm we are accomplishing our task. Algorithms that often extend, optimized and replace during development and reuse. So we need to use a latest algorithm, so that, and even that algorithm should be in such a way that it should be understandable. It should be you should be able to understand it, and then whenever you want to make it, you can even alter that algorithm also, because reuse is one of the most important concept in the while building any application or by building any software architecture. Tight coupling, classes that are tightly coupled are hard to reuse and isolate, since they depend on each other. Tight coupling leads to monolithic systems where you cannot change or remove a class without understanding and changing many other classes. Tight coupling means more dependency. If you have some in your application, five classes, so five classes are should be must and should be there. You cannot remove one or the other class. So in that tight coupling environment also, your software should be in such a way that you should be able to change it. Okay, I have taken an example to make you understand by using five classes. Classes are tightly coupled means these classes, the five classes which I have taken, are hard coded. Hard coded means they are dependent on each other to run some application. If I disturb any class, the whole application might not work as per your expectation. Okay, so even then, you should design in such a way that by disturbing some or the other class, the major part of the work should not be stopped. Extending the functionality by subclassing. What is this extending the functionality by subclassing means? It is nothing but inheriting. Okay, more and adding inheritance means what? More and more functions are to be added. So whenever you develop any application, uh, as the day progresses, you need to add few more features for that. Okay, so whenever you add few more features for that, your classes goes on, the application goes on increasing. So that can be done by using subclassing concept or child classes, even you can say. Uh, Here it tells the explanation regarding that inability to alter classes conveniently. Inability, sometimes you have to modify a class that can't be modified conveniently. Perhaps you need the source code and don't have okay, inability to alter the classes conveniently because of the hard coding. You may not be able to alter the classes conveniently. So that is also a major issue which comes into consideration while designing for a change. Okay, what are application programs? Application programs, whatever you build whatever you write the application. So those are called as an application program. Till date, you have done a lab programs that it is doing certain tasks definitely, but if it is application, when you call it as an application program, it should do certain tasks. So like here they have given an example like a document editor. If you take a notepad, you know what is the notepad, what notepad does. If you take Excel, for that we call it as a spreadsheet. And what is the major thing in this application program is it should be a reusable one. Maintainability and extension are high priorities. Whenever you take any application program, the main aim of the application program is whether it is reusable or not, whether it is maintainable or not, or whether it is extensible or not. Internal reuse ensures that you don't design and implement any more than you have to. Okay, the reuse concept is always it has its own importance. Design patterns that reduce dependencies can increase internal reuse. Internal reuse design patterns, always I say design patterns whenever I read this word called as a design pattern. It should be in such a way that there is some solution for the existing problem. We just take them and then we solve our problem. Looser coupling boosts the likelihood that one class of object can cooperate with several other classes. Tight coupling and loose coupling. Loose coupling means independent classes. Maybe it is independent class. Tight classes means there is a strong bonding between one class and the other classes. For example, you are eliminated when you eliminated dependencies on specific operations by isolating and encapsulating each operation, you make it easier to reuse an operation in different contexts. See, whenever you have an encapsulation concept, one operation is being encapsulated, and it makes you easier for reuse. And what are toolkits, frameworks, and all? So we shall see in our next module. Okay, next class or next video. Toolkits, frameworks, and how to select a design pattern, how to use a design pattern. So that completes your first module, and we have stopped at this point, and that is toolkits. We'll see whether a toolkits section will can be complete. Toolkits are nothing but okay. Toolkits are nothing but it's a kind of a settings given for the application programs. To be frank, it is an adjustment in your applications. Toolboxes you see tools in your application. Certain settings, if at all you want to change, that is present in the toolkit. And in your context, it is implemented by using a C++ IOStream library. Is another example. Toolkits don't impose a particular design on your application. They just provide functionality that can uh, help your applications do its job. Okay. See, whenever you see this part, it will help your task uh, to accomplish easily. Toolkit design is arguably harder than application design. Why? Because see what the designer, I mean what the user wants, designing the settings is even difficult for that. So that is the point which is highlighted over here. Moreover, the toolkit writers isn't in a position to know what those applications will be or their special needs. So what settings I want, the developer should know. That is the most difficult part. Toolkits, in if you see the Microsoft Office, or if you see Microsoft Windows itself, so there is a control panel. What that control panel will be, a control panel is used for enabling the or disabling the settings of a particular section of your computer. Like if you want to disable uh, the IO ports, or if you want to enable the IO ports, if you want to disable the IO devices, if you disable the USBs even, so that can only be accomplished in the toolkits section. That is, for that toolkits, we are not telling it as a toolkit uh, in the Windows 7 or so. We just call it as a control panel. Okay, with this explanation, let me wind up this video at this point, at this slide. We shall I shall continue the same module in the next video. Thank you.